Hi there, so we're going to chat through the answers to yesterday's question, and I've got today's question for you. I'm going to say it straight off the bat so that you can get thinking about that, and then I'm going to talk about some of the best answers and some tips for the last one as well. So today's question is, describe a method that a student could use if they have got a tennis ball and this tape measure and a stopwatch, which is the stopwatch on a phone, which I'll show you my phone, but I'm obviously using it to do the live stream. So describe a method a student could use with those three things to measure gravitational acceleration. Include data they should collect and any equations or calculations they need to use. Now, A-level students, I'd expect a graphical method for this one, absolutely, for determining G. So think about G by Freefall there. And bonus points, other things you can talk about, suggest other apparatus or other techniques that they could use to improve the accuracy of the method. So that is, describe a method that a student could use with a tennis ball and a tape measure and a stopwatch to measure gravitational acceleration G. Include any data, include any calculations they should use as well. So let's talk about the last one, which was the safety features on a plug. Now, really think about these questions I'm giving you as revision questions rather than just exam questions. They're revision questions in that they should get you thinking, and they should get you thinking about applying some ideas to the context. So this, even if you're A-level, and yeah, they don't specifically talk about mains electricity at A-level, but it is a context for which you can apply some of your other knowledge about current, power maybe, and other things like that. So don't think to yourself, oh, this is a purely GCSE question or an A-level one. There were some really, really great responses. I would, Harriet's, I think, is the best sort of concise summing up the safety features, going through how there's a fuse with a live wire that melts when the current is too high, and that breaks the circuit, and therefore that current flows down to earth, which is a very low resistance path for current. So that's really, really good. Also, I think she said that it's double insulated, so that's what the square within a square means. That tends to mean the appliance itself is plastic, so there's no chance of the appliance case becoming live. But it's not the only reason. Double insulated, it just means that there is no chance of the person getting into the circuit. There's no chance of the thing becoming live itself. And what I actually showed you was my charger for my phone. That was the one with a plastic pin. It doesn't need an earth wire because it is the device itself. It's the transformer on that actual plug there, which is the device, and it's a double insulated device, meaning it's got a plastic case within a plastic case. Okay, so that was a great response. Some of the A-level ones, Human Snake gave some really good detail about how you might calculate power dissipated for a person, and how you might, if you knew the resistance of a person, how you might be able to work out the current and therefore the power, and therefore the idea of how likely there would be of a serious injury, although they didn't go as far as actually doing the calculations. They sort of mentioned them. That was good. 230 volts is the RMS voltage, which means a root mean square voltage. And one of the responses that I got by email was really good at showing a graph of that kind of sinusoidal wave, which is the AC kind of going from positive to negative. And if you're just describing the difference between AC and DC, AC changes direction or goes from positive to negative, whereas DC always stays the same, or positive, all the way along. So it was really, really good. The 230 volts in the UK main system, 50 hertz was the other detail in there. Think about what the question doesn't tell you. And if you know there's a kind of key detail like that, 230 volts, 50 hertz, then get that detail in there, because that will be one of the marks. If they didn't tell you, they said, oh, there's a symbol with a square within a square, they don't tell you what it is, then they're probably expecting you to say, that means double insulated for one of the marks. So well done. 230 volts is what you call the RMS voltage, which if you average a sine wave, you're going to get 0 because it's constantly going positive and negative. So if we want to work with the kind of average voltage, then we have to square all the values first, then average those, and then root the answer to give you the root mean square voltage. So whenever you're averaging something that's changing direction all the time, you use what's called a root mean square. Okay, average if you like. And 230 volts is the average. So the peak voltage is 230 volts times root 2. is this conversion factor of √2 between a peak voltage and an RMS. So the peak voltage is actually 325. So when you look back into the answers, if you go back to the answers from the people who've left on the last video, have a little look through them. There's some great examples in there, and I'll leave comments of what the best and kind of not such a, well, any corrections might be. So I'm going to get to the chat in just a second. Some great responses by email as well, which is perfectly fine, but be confident because your responses are great. So go ahead and put them in the comments. One of the reasons for that as well is that YouTube likes it when videos get comments and they think, oh, that video is really getting people engaged. So go ahead and they will send that video to more people. So you help me out just by leaving a comment on my videos, please. The best thing about this task is applying your knowledge to context, which is a really important skill you need for GCSE and A-level. Thinking about the context that you've been given and applying some knowledge that you've got, bringing your subject knowledge to solve the kind of problem. Okay, so today's question, how can you use this tennis ball and this tape measure? Notice the tape measure is up to 3 meters. How can you use tennis ball, tape measure and stopwatch to give a value for gravitational acceleration? And A-level students, I'm expecting a graphical method. So how are you going to get a graph and how you're going to use that graph to work out G. GCSE students, you might want to go into that as well. It's really interesting. Or you might want to just give the data you collect and any equations you might use. That's perfectly fine for GCSE level. Bonus things is how can you change the apparatus and techniques to give you a more accurate value for G. Okay, you might even compare the value you'd expect with the real value, say whether it be higher or lower than that. Quick look into the chat and then I'm going to go. My friend who says A-level says SUVAT is really useful. Is it relevant for GCSE? SUVAT in the GCSE you do, Rachel, is only the v squared equals u squared plus 2as, or the v squared minus u squared equals 2as, I think is the way that they give it. Final velocity squared equals initial velocity squared minus 2 times the acceleration times the displacement. That's the only equation you need to use, but knowing the other SUVATs could be useful. But I would just stick to learning the equations that you get given in the equation sheet that you need to memorize. Using my book, maybe memorize equation for GCSE Physics and just learn those. There is a SUVAT page in there in that book, but I wouldn't worry too much about learning extra stuff. I'd learn those and make sure I know how to apply them because they will be the tools to solve all of the calculation questions. Somebody asked, how do you revise practical stuff and how do you know where I can find a list of apparatus with its uses? One of my videos is all of the core practicals for A-level physics. That might be good. If it's GCSE, then I haven't got a video. I'm going to do a video, all of the core practicals in GCSE pretty soon. There is a list of apparatus and things. So I've got quite a few videos where I explain what you need to know for practical skills. So if you Google or if you search in YouTube Guerrilla Physics practical elements or practicals GCSE or something like that, then there's loads of kind of advice of how to revise those practical things. Basically doing this, like take a practical, make sure you know exactly how to describe the method, but also that you know the data collect and that you know how to process that data to get your results and how you know how to improve it, you know, the typical kind of evaluation points. That's the most important thing. All of the exam boards do make sheets which are methods for and some typical data and some things like that for each practical, and if you learn those bits you can't really go wrong. I have a video on light gates as well for GCSE or A-level. Yeah, so if you're A-level then addy daddy whatever your name actually says, then definitely check out it is currently my most popular video. It's all the core practicals, Guerrilla Physics. You can't really miss it if you just search for those things and go through that. I go through them really succinctly, and if you kind of learn those bits, then you'll be golden. I have a good video of it's actually G by Freefall with some light gates. It's not a graphical method, so you need to add that on to your answer that you're just going to leave in the comments to today's daily revision question. And what's the difference between leads and flying leads? There is no difference. A flying lead can just be moved. It just means that it's a lead that you can connect normally in different places. For example, in the resistivity practical, I've got a good video for resistivity practical as well. If you search that up, it's really popular at the minute. It's just the lead that you're actually moving to change the length of the bit of wire that you're investigating. Hope that makes sense. Okay, I'm going to one more time just run through the questions. If there's any more questions, then you can feel free to ask. Remember, this is just a bit of fun, really, a bit of a kind of method, just some ideas for you to revise with, okay? So make sure that you're subscribed. This is all about applying your knowledge to some different contexts. Make sure you think of an answer, leave it in the comments. It's not a competition. But yeah, every day I'm going to pick out a good GCSE and a good A-level style answer for you to go back and have a little look at. Well done, Harriet, for the GCSE answer. Well done, Human Mistake, for the A-level answer. That's really, really good. Subscribe so you don't miss anything, any of these, okay? Join us. Look back at the last two as well if you haven't. Join us. This is all about you getting your best grade, okay? I am all about you working to the highest levels to get the grade 9s, get the A stars. Okay, and I'll see you tomorrow when I pick the best A-level and the best GCSE answer. So this question, how can you use a tape measure and a tennis ball and a stopwatch, which you'd have on your phone, to get an accurate value for G? How could a student use those 3 bits of apparatus to get an accurate value for gravitational acceleration? Include data or calculations that they need to collect, and calculations they need to use, equations or calculations they need to do. A-level students, we're expecting a graph. How can you get G from a graph from this data? And bonus ideas suggest other apparatus or techniques that you could use to improve the accuracy of your result. And I think that's it. No other kind of questions. Thanks for sharing. Then yeah, do post me a kind of do post me an answer. Use it to revise this one. You might be able to, Rachel. Okay, you have a little think about that. A little think about the data that you can collect and what you can't collect using this. Think closely about whether you can really measure with those things final velocity or initial velocity. Do you know something about initial velocity? Do we have to talk about energy? No, not necessarily, but energy is usually a good workaround. Normally there'll be some clue in the question as to how you're going to talk about energy. You might want to look back into your revision guide. This will definitely be for both GCSE and A-level, a big section, because it is one of the core practicals. Not necessarily a core practical about gravitational acceleration at GCSE, but it is definitely, how you measure acceleration is definitely a key idea. So make sure you're good at describing a method, and this is what it's going to be. You can email me questions, and my email address is kit@gorillaphysics.com, and you're very welcome to do so. I can't promise always to respond, because I do get quite a few emails. I do try my best. Some people on here will testament to that, and I like to receive those emails, but they often become things that I look at in later videos and other things like that. So I'd love to hear from you if you've got a question. I can't promise to do everything that you need from me, but you know, I'm very glad to hear from people. All right, thank you very much. Have a go. I look forward to reading your comments. I'm really enjoying this. I hope you are as well. I look forward to reading your answers and your comments to this one. How can you measure G by freefall?